Hello everyone, this is lesson 10.5 and 6, miscellaneous angle and segment relationships in circles. So these two are the last lessons where you'll learn different segment and angle relationships, and then we'll talk about how to find the equation of a circle and how to use the equation of a circle to graph the circle, and then that'll be the end of the unit. So, and honestly, this is going to be split up into 2 days. We could probably squeeze it into 1 day, but I just don't feel like that's necessary. So we're really probably just going to do 10.5 today and then 10.6 in tomorrow's lesson, where normally I would try to squeeze this all into 1 day. So anyways, we're going to do a couple theorems. Let's see, we've got 3 theorems and then some practice examples. So the first theorem, Theorem 10.5a, if a blank and a blank intersect at a point on a circle, so what do you have here? You have a tangent, and this you have a chord. So if a tangent and a chord intersect at a point on the circle, here, point A, then the measure of each angle formed, so we're talking about this angle, angle 2, and angle 1, is blank the measure of its intercepted arc. So 1/2 the measure of its intercepted arc. So for example, if arc AB, let's say arc AB is 100, then the measure of angle 1 would be 50. And then let's say arc ACB is 260, so then the measure of angle 2 would be 130. Okay, and this is pretty easy to see. If the whole circle is 360, and then this chord and the tangent split it up into 2 parts, then the measure of this line must be 180, so it must intersect correspondingly. So that's a pretty easy one to see. But sometimes diagrams can be funny, and they can make it so it's adding extra information and make it hard to figure out. So that's 10.5a. 10.5b, angles inside the circle theorem. Okay, so let's say you've got 2 chords that intersect inside a circle, because next we're going to do outside. So you've got chord AC, chord BD. Then the measure of the angle, so we're talking about angle 1, is 1/2 of the sum of the measure of the intercepted arc by its angle and its vertical angle. Okay, so this is tricky here. So the measure of this angle is not just the measure of the intercepted arc, because it's not a central angle. Not a central angle. And it's not just 1/2 of the arc, because it's not, what do we call that? An inscribed angle. So this type of angle is just an angle inside of a triangle. Okay, it's not a central angle, it's not an inscribed angle. It's an angle formed by 2 chords that intersect inside of a triangle. So to figure out the measure of the angle, you would add up the arcs that it is created by and then do 1/2 of that. And notice that whatever angle 1 is, that's what this angle is also, because they're vertical angles. Then whatever angle 2 is, that's also this angle. So it doesn't matter which one you're looking at, because they will both be the same. Not angle 2 and angle 1 won't be the same, just the vertical angles will be the same with each other. Okay, and then the last one is angles outside of a circle. So if a tangent and a secant, 2 tangents or 2 secants. Okay, so back up. If a tangent and a secant, that's situation 1. You've got a tangent and a secant. Or if you have 2 tangents, okay, 2 tangents intersect outside of a circle right here, or 2 secants, situation 3, like 2 secants right there. Now notice that in each situation, the arcs that are created are a little bit different. So here, the outer arc and the inner arc, here you've got this outer arc and the inner arc create this whole circle, and then this outer arc and this inner arc. So intersect outside a circle, then the measure of the angle formed is 1/2 of the difference, so not sum anymore if it's outside, but difference of the measure of the intercepted arcs. Okay, so first of all, you have to figure out what these arc measures are, and then second of all, because it might give you like AB and AC, and then it might ask you to figure out what BC is first. Okay, so make sure you're paying attention to what you have. So let's do some examples. And then we'll also say which theorem we're working with. So find the angle and arc measure. So line M is tangent to the circle. Find the measure of the red angle or arc. Okay, so we're finding the measure of the red angle. So this is 10.5a. So the measure of this angle would just be half of the arc it intercepts. So 65 degrees. And then here, they're giving us the measure of this angle, and they're asking us to find arc KJL, which is going to be twice 125, so 250. Okay, pretty easy so far. And then looks like we're still working with 10.5a in these examples. So to figure out the measure of angle 1, you would do 1/2 of 210, which is 105 degrees. To figure out the measure of arc JSR, you would do twice 98, which is 196. To find the measure of arc XY, you would do twice 280 or twice 80, which is 116. Okay. Is there anything below that? No. All right, next we're working with looks like we're going to be working with 10.5 B and C. Okay, so here this would be 10.5b. So to figure out x, you would do 1/2 of the sum of 130 and 156. So 1/2 of 130 plus 156, that's how I would set up my equation. And then that would be 286, and 1/2 of that would be 143. Right here, to get x, you would do 1/2 of the difference. So 1/2 of, and it's always the outer one minus the inner one, obviously, because you want to keep everything positive. So that would be 1/2 of 102, which is 51. Okay, easy math for now. And then how about this one? Okay, so this is one of those where they don't give you necessarily everything you need to know. So if you want to find why is this arc, which is intercepted from this angle here, and then you're not given this angle though, you're given 102, but to find it you just do 180 minus 102, so this would be 78. Okay, and then now we're given 78, so this would actually be 78 equals 1/2 of y plus 95. So now we've got an equation that we actually have to solve for y in. All right, so what you can do first is, if you want, you can get the 2 over to the 1/2 over to the other side by multiplying by the reciprocal 2. So this would be, 156 equals y plus 95, because the 2 and the 1/2 would cancel, and then minus 95 on both sides, and that would give you 61. All right, and then angle A. So this is another one where you'll have to work backwards because you're given the arc, or you're given the angle measure. So 30 equals 1/2. And then we're going to do the outer, which is A, minus 44. That's important because if you don't do that, then you're gonna get it messed up. Okay, so then once again, multiply by 2 on both sides. So you get 60 equals A minus 44. Add 44 on both sides, and you should get 104. Okay, so that's the end of these examples. And then next we'll do lesson 10.6. Okay, so I hope you enjoyed this lesson. That was a little bit shorter than usual. You guys have a great day.